In this example, we're going to apply many of the ideas we've previously discussed. The graph of f of x is given, and then we're told to find the following. Now, let me first describe what this graph looks like. This graph decreases, coming from the left and the bottom left, actually, of our graph. And I'm going to draw an arrow to indicate that it continues in that direction. Now, the graph increases from the bottom left up to the point -1, 0. It continues increasing until it gets to the point 2, 3, the ordered pair 2, 3. And then it decreases to the point 5, 0, where we have a closed dot. Now, the first thing we are asked to find is, for part A, is domain of f. And because the graph continues to the left, but it has a closed dot at the point 5, 0, our domain, because that is x values, is going to be parentheses minus infinity, comma 5, bracket. Now part B asks for the range of f. The range is the set of all y values. So we want to take note that this function is falling to the left, it's decreasing to the left, and that it has a maximum of the point at the point 2, 3. So the y values that this attains is going to be this interval, parentheses minus infinity, comma 3 bracket. Because 3 is the highest point, and it is included because there's not an open dot. Part C is the X-Intercepts of f, and there are 2 points where this intersects the x-axis. One of those is the point -1, 0, so parentheses -1, comma 0, close parentheses. And also, we have the point 5, 0, so parentheses 5, comma 0, close parentheses. Those are the 2 x-intercepts. Now, I'm listing these as points, but there are times when we consider the x-intercepts to just be -1 and 5. I'd prefer to use points for this. Now next, part D is the Y-intercept of f. And it appears, I didn't say this in my description, but it appears that this graph intersects the y-axis just under 2. It looks like that's between 1 and 2, so I'm going to say that that's 1.5. So that y-intercept would be the point, parentheses 0, comma 1.5, close parentheses. Part E, we want to find f of 2. Well, because we have the point 3, 2 on our graph, that is, when x equals 2, y equals 3, f of 2 equals 3. Typically, graphically, you find this by going to where x is equal to 2, since it is f of 2, and tracing up until we find our graph, and the y value at that point is 3. Therefore, f of 2 equals 3. Now, similarly, for part F, we want to find any values where f of x equals -5. F of x is another way to say a y value, so we're going to go to where the y value is -5. And on this graph, I'm going to trace to the left, and my graph, the x value at that point is -3. So we have the point -3, -5. So where f of x is -5, we have an x value, x equals -3.